We'll be going over the last couple of questions in part 1 of the short response section of the January 2013 Algebra 2 Regents exam. So let's start with question 31. Question 31 gives you some data of 10 high school varsity basketball players. So it gives you their height, and it asks you to find the interquartile range of this data set. So anything that deals with the median, or range, or interquartile range, or quartiles in general, you should, the first step you should take is to order the data from the least to greatest values. So if we were to do that, we would have 71, 71, 72, 74, 74, 75, 78, 79, 79, and 83. So in order to find the interquartile range, you need to find the median of the lower 50% and the higher 50%. So for us, I guess the best thing to do would be to split the data into two groups, the lower 50% and the higher 50%, and that split would occur right here with 5 values below and 5 values above that line. The next step is to find the medians of both those two sets of data that you have now created, and so the middle number here would be 72, and the middle number here would be 79. And the final step in order to find the interquartile range is to subtract the 75 percentile from the 25 percentile that you have just found. So you have 79 minus 72, and that will give you your interquartile range of 7. The couple of key things to remember here are that what we did first was find the 75th percentile and the 25th percentile. So you could have also divided the data up by quartiles rather than by the half, I guess, so dividing the data by half and then finding the median of each range. But that's basically the same thing. I just figure this is a simpler way of looking at the problem. Alright. Question 32 asks you to solve an equation that they give you, and this one is it's a pretty straightforward question. You should know that there's no simple root to this, and the reason you should know that is if you use the part of the quadratic formula that helps you figure that out, you'll figure out that it is a non-real number. A non-perfect number. So if we use the quadratic formula now to actually find the answer, we know that the formula is negative b plus or minus radical b squared minus 4ac all over 2a. And we have all those a, b, and c values on the top, so when we plug all of that in, you get 2 plus or minus radical negative 2 squared minus 4 times 6 times negative 3 over 2 times 6. Right, so now that you have all those values plugged in, you go ahead and simplify that. So under the, you have 2 plus or minus, and then under the radical sign, you're left with 76, and on the bottom, you have 12. And so then you have to simplify the radical 76 on top in order to put it into the simplest form. And radical 76, you have to figure out what perfect square you have in there as a factor. And if you think about it, 4 and 19 are the two numbers that multiply together which have a perfect square as one of the factors. So you have 2 plus or minus radical 4 times radical 19 all over 12. You can go ahead and simplify radical 4 into 2, which leaves you, and we're going to go over to the side here, which leaves you with 2 plus or minus 2 radical 19 over 12. And you can go right ahead, simplify the 12 with both those 2's, and you're left with 1 plus or minus radical 19 over 6. And that would be your final answer. Alright, so the next question deals with an exponential formula, and you have n is equal to 50e raised to the 3t power, and they tell you what in one instance of n, and they tell you that it's equal to 30,700, and they ask you to find the number of hours. So now if we write that all out, you're left with 30,700 is equal to 50e raised to the 3t power. First thing you do is divide by 50 and get the exponent on its own. That leaves you with 614 is equal to e raised to the 3t power. Now, the next step is to find the natural log of both sides in order to get rid of the e from the first side. So let's go ahead and do that. You have ln, the natural log, 614, and then you have the natural log of e raised to the power of 3 times t. So the couple of things happen once you do that. You're still left with the ln 614. Sorry, let me quickly fix that. You would still be left with the ln 614 on the left side, and then when you take the natural log and the e cancel each other out, which leaves you with just 3t on the right side. You divide by 3, and you can go ahead and plug that into your calculators to find out what ln 614 equals, and divide that by 3, and your final answer comes out to be 2.14 being equal to t. Question 34 gives you an inequality and asks you to determine the solution of that inequality. So you're going to get two answers for this. So the first thing you need to do when you have an absolute value in your inequality is to set up two separate sides of the equation with the right side of the equation negated on one side and of course the sign flipped for that as well. So on one side you have 3 minus 2x, just like it is currently in the problem, is greater than or equal to 7. And on the second side, this is the one that's a little bit tricky, is you have 3 minus 2x, you flip the sign, and you negate the answer, and you have, so that is equal to negative 7. So once you have that done, you can go ahead and solve each one separately to figure out what x is equal to, or not equal to, but is what x is related, how x is related to 7 and negative 7 on both sides. So why don't we go ahead and solve for that. So you subtract a 3. That leaves you with negative 2x is greater than or equal to 4. And you divide by negative 2. And since you're dividing by a negative number, you must flip the inequality sign. So that leaves you with x is less than or equal to negative 2. Now, on the second side, you go ahead and also subtract by 3. That leaves you with negative 2x is less than or equal to negative 10. Divide by negative 2, and if we remember from the other side, because we are dividing by a negative number, we must flip the sign again. So you have x is greater than or equal to 5. And those two relations are the solution to the inequality. Now we'll go over the last question in part 1 of the short response section for the January 2013 Algebra 2 Regents exam. This is a pretty straightforward question that asks you to convert 3 radians to degrees and then express the answer to the nearest minute. So the first step here is to know the formula for converting from radians to degrees, and that would be you take its radians times 180 divided by pi. And if you plug it into your calculators, you'll get 171.89. Now the key thing here is to know how to use the calculators for this, because that, quite frankly, is the simplest way to figure out an answer like this. If you plug it into your calculator, you put 171.89, and you click the buttons that will allow you to display that number in the minute and degree form, and that will tell you that your final answer is 171 degrees and 53 minutes, and that would be your answer. If you wanted to do it strictly mathematically and not use the calculator to find the number of minutes, you could do 0.89, right? So you have 0.89 hundredths. Well, you have 89 hundredths, not 0.89 hundredths. And you're multiplying, and you can multiply that by the number of minutes in a degree, which is 60. And if you do that, you get 53.4, and that you simplify to the nearest minute and find 53. So if you are a little bit calculator shy, that is the mathematical way of doing that.
Made with Doodlecast Pro.